Alright, and the final binomial distribution problem we'll do is from the textbook. This is page 624, question 13. Usually the questions towards the end of the sections are the more difficult ones, so we'll see how this goes. A new drug has a 75% probability of curing a patient within 1 week. If 38 patients are treated using the drug, what is the probability that between 24 and 31 patients inclusive will be cured within a week? So what we want to do first when we get a problem like this is think about how do we know this is a binomial distribution. So first thing we look at is the probability, 75%. That's fixed. It doesn't mean if it works for someone, it has a better chance or worse chance to work for the next person. It's still 75. And then the next person, still 75. So the probability of success is fixed at 75. Then, for a binomial to be a binomial, we need it to have a number of trials. And if we look over on the top right, 38 patients are treated. That's our number of trials. We're giving this drug to 38 people. Then, our R value, and this one is where it gets a little trickier, because we need between 24 and 31 successes. And that's inclusive, meaning we can include 24 and 31. So that means we want 24, 25, all the way up to 31. So what we could do, we have some good options and bad options. So 24, 25, 6, 7, 8, 9, 10, 1. We could do 8 binomial PDFs on our calculator, spend quite a bit of time doing that, and then add them together. I think you can see quite simply that that's not a good way to go about this problem. Instead, let's try and use our binomial CDFs. So what we show first is that we understand this is a binomial. N and P goes on the inside. That's step 1 to show. Then our first probability statement. We are looking for the probability that X is between 24 and 31. So that's our first probability statement. We can't do that on a calculator, however, so we need our second probability statement of what we're actually going to do. We could take the probability that X is less than or equal to 31. So that gives us 31 people and every other option less than that. Now that includes 30, 29, 28, 27, 26, 25, and 24. However, it also includes 23, 22, 21, and so on all the way to 0. So what we want to do is get rid of the probability that X is less than or equal to 23. So 31, this first part, that gets us from 0 all the way to 31. If you look back up here, we only wanted from 24 to 31. So we're going to get rid of from 0 all the way to 23. And what that leaves us with is what we want, 24, 25, 26, 27, 28, 29, 30, and 31. So on our calculators, we go to second distribution, we go to binomial CDF, trials, there are 38, p-value 0.75, x value 31. We hit enter, and enter again, we get 0.8718, and then we need to do the second one, second distribution, binomial CDF, trials 38, p-value 0.75, and our new x value for this one is 23. That gives us 0.0348, and then we take the first one minus the second one, all on our calculator, and we get 0.837, 3 significant figures. And this is exactly what you'd want to show. So the keys, again, of what you need to make sure to show, that you know it's a binomial, the general probability statement, and then our adjusted probability statement of what we're able to do on a calculator. And then obviously you want the answer. It's a good idea to also show these numbers here. Technically probably not necessary, but again, when in doubt, show more than you think you might need to.